All right, let's go over our geometric probability problems. And so this first one here asks about the average number, or how many do we expect to have to look at until we find a colorblind male? Well, this is coming from the formula chart. Okay. So when we had our formula chart here, then what we were dealing with was this little section down here that says for geometric distributions, the mean and the standard deviation. So those were the formulas we used there. And so we got 12.5 men is how many we expect to have to go to find one. And that's an average with that standard deviation of 11.99 men. All right, but now what's the probability that she won't find anyone colorblind among the first four? So that means all those first four people she checks are not colorblind. So that's 0.92 to the fourth. So they are all not colorblind. And FYI, the work, you do need to show this work. Nothing I have written here is extra, including the units. Okay, so including these units here, we need to keep those in mind. All right, next is our probability that the first colorblind man is the sixth person. So do not just write the calculator speak. In fact, what I have written here in blue is extra information. It means nothing for AP graders. It's this idea that we have 5 failures and then a success, a colorblind man on the sixth person. So there is our probability. That's how I calculated it with the calculator if you wanted to use that shortcut. Now, what's the probability that she finds someone who is colorblind among the first 5? So that means the first one could be colorblind, or the second one could be colorblind, and then that's the sequence, all the way up to that fifth one being the colorblind person. Now, if you were to show this process, you had to show the sequence. You did not have to include that piece right there in the sequence. You have to show the first up to the last in the sequence. Then come on over here to your calculator and compute. You want this success to occur, it's cumulative, on or before the fifth person. So that includes that fifth person. All right. Now, some of you might have thought of this whenever you read this. She finds someone who's colorblind among the first 5. So some of you might have thought that that means really she's finding at least one. Okay. So that's everything except for none of the first 5 being colorblind. And so look at that. They came out to be the same probability. So here we see, that we've got multiple ways that you can think of the same situation. And that's what F asks you. They have the same probability. What's the similarities and differences? Well, in part D, when the success occurs on that first trial, you could have anything else happening after it. So that's what kind of translates then to making it at least one success among those 5. All right, now here is an extension that's really going to lead us into the next lesson. So we have this: you won't find the first colorblind person until after the 15th person. So the 16th is the first place that could occur. 16th or any time after that. So I don't care when that first success occurs as long as it is not in the first 15. So that's what I defined here. Mathematically, no colorblind person amongst those first 15. And that's what that came out to be. Now, again, with the next lesson, you could also think of it as 1 minus a success on one of those first 15 trials. So 1 minus that geometric CDF of a success happening in those first 15. So people think of things in different ways, and both of these thought processes are acceptable. All right, next we have the left-handed people. So, on average, how many you think you expect to look at until you find one? Well, there's that formula, that one out of the probability of success. Okay, this many people on average. It's okay to have a decimal because it's the average. And then here's that standard deviation. What's surprising to me when I've looked at all of these is how close that standard deviation was to the mean. So that was interesting. It seems quite varied, if you ask me. But anyway, there you go. Okay, now, what's the probability that the second or the third person you check is the first one who is left handed? So you have to put this work down. There's not a shorter way. You show a failure, then a success, plus two failures, and then a success. There's no other way to do that shorter. So that had to be there, just like that. Here's that answer. Now, if you had done this in your calculator, you could have computed it this way. 13, the point 13 happens on the second, plus the point 13 happens on the third. Okay, so there's mathematically how you would have come up with that 0.211 if you chose to use a shortcut on the calculator. Here, what's the probability you won't find that right-handed until the third? So two lefties and then the righty. Okay. Oh, that's the right-handed person. Okay, so make sure that you are putting the correct handedness in the correct place. So here is one that we want to find that first left-handed person. So our left is our success among those five. So the first, and then you don't have to put that second term in there, but you have to have that first term up to the fifth term being the first success. Now, calculator wise, that could have been accumulation of 0.13 being anywhere up to and including that fifth spot. Up to and including that fifth spot. All right. Now, looky here. What's the probability that you won't find any right-handed among the first five? So that means they are all lefties. Well, look at how small of a probability that was. When you see that, if you see 3.71, you can't have 371% chance. Make sure you look at the end and see that it's decimal times 10 to the negative fifth. So that's essentially a 0% chance that the first five people are going to be lefties. Okay. And then here we have our probability of at least one. It's 1 minus the probability that none of the first four people are lefties. So they're all righties, and so there you go on that. And how about this one? What's the probability you won't find the first left-handed person until after the 10th? So that means the 11th and on. So the first 10 are all righties. So it looks like that. And again, and we'll bridge into this with the binomial lesson today, or actually tomorrow when we do accumulations. You could also think of this way. All right. I hope that clears up, and I hope you did okay on your geometric probabilities.